Gate 2024 physical metallurgy questions. Match the laws listed corresponding to the material properties listed. Hooke's law. Hooke's law tells us about Young's modulus. Fick's law is for diffusivity, and Fourier's law is used to calculate thermal conductivity, and Darcy's law is for permeable. So Hooke's law says that sigma is equal to E into small u, engineering stress strain. The linear relationship between stress and strain in an elastic material, and the Young's modulus is a proportionality constant in this relationship. So the strain in a solid is proportional to applied stress within an elastic limit. Fick's law says the diffusion of particle through a medium, the diffusivity is proportional to the constant diffusivity into the concentration gradient. This law describes that flux goes through region from high concentration to low concentration, but its magnitude is proportional to the concentration gradient. So, dou by dou x is concentration gradient, D is the diffusivity, and J is the diffusion flux. If you see Fourier's law, this tells us the thermal conductivity. It describes the conduction of heat in a material, and thermal conductivity is proportional to the is proportionality constant in this law. This law is that the time rate of heat transfer through a material is proportional to the negative of temperature gradient. So through which the heat flows. Q is the heat flux, K is the thermal conductivity, and dT by dx is temperature gradient. Darcy law is linked with permeability. It describes the flow of fluid through a porous medium. The permeability is a property of medium that determines its ability to transmit the fluid. So Q is equal to minus K into delta P by mu L. This law describes the flow of fluid through porous medium, and the velocity of the fluid through the bed of a granular material directly depends on the pressure drop and inversely upon the viscosity of the fluid. The following schematic represents the variation of the rate of nucleation of solid of pure liquid metal as a function of undercooling and the freezing. So if you'll see for the nucleation, the variation of nucleation from solid to pure liquid metal as a function of undercooling typically is a curve uh, which increases the nucleation rate, which increases abruptly and then reaches a higher point and then it decreases. This is because undercooling increases the critical radius of the nucleation decreases, which means there is a large increase in the rate of formation of critical nuclei. However, reaching a peak, the rate of nucleation decreases due to increasing viscosity of the fluid. The curve represents the variation of rate of nucleation with undercooling. It initially increases with undercooling and reaches a peak and then decreases. So, this is the answer. The following crystal structure changes during transformation of mild steel to austenite to martensite. Generally, uh, the when you consider austenite to martensite transformation, if the carbon is greater than 0.3 percentage, you'll get BCT structure. So FCC structure will be converted to BCT. If it is less than 0.3 percentage or 2.25 percentage, you'll be getting BCC structure because there are no enough carbon for it to stay there itself. So the C by A ratio is almost equal to 1. The structure will change from FCC to BCC itself because almost is equal to alpha only, 0.025. So the right answer is face center to body center and face center to body center cubic. So A and B both are right. Which one of the following HKL reflections is allowed in X-ray diffraction of face centered cubic? You will see for a face centered cubic, you have only the either HKL all should be odd or all even. So mixed, unmixed. This is called unmixed. So mixed plane values are not required here. This is due to the structure factor of FCC lattice. So 0, 1, 1 is mixture of odd and even. So it is also mixture of odd and this is even and this is even. So only C and D is allowed. The pair of the interaction energy between two atoms is given by the following. U is equal to minus 1.6 by R power 6 plus 51.2 by R power 12. The U is interaction energy. The interatomic distance is A naught. The equilibrium bond length between the atoms is dash. So if you wanted to find the equilibrium bond length, you have U as 1.6 by R power 6 plus 51.2 by R power 12. So you need to find dou U by dou R equal to 0. D by dr of minus 1.6 by R power 6 plus 51.2 by R power 12, which is equal to 0. So you will get 9.6 by R power 7 minus 614.4 by R power 13 equal to 0. So R power 6 is equal to 64. So R equal to 2. So 2 is the answer. Equilibrium bond length is 2. For a solid embryo in contact with perfectly flat mold wall, as shown in the figure, the wetting angle is theta. So if you will distinguish this, this is um, the this is gamma solid liquid. This is liquid, so liquid mold, and this is gamma solid mold. So you have uh, gamma liquid mold equal to gamma solid mold cos theta plus gamma solid mold. So this is equal to liquid mold is 0.35, solid and mold wall is 0.02, and this is equal to 0.4, which is equal to 0.02 will be sent this side, it will become 0.033 by 0.4. So cos theta is equal to 0.33 by 0.40, which is equal to so theta is equal to cos inverse of 0.33 by 0.4, which is equal to 34.4 degrees. So wetting angle is 34.4. In a cubic lattice, what is the ratio of interplanar spacings of 100, 110, 111? You know, interplanar spacing D is given by A over root over H square plus K square plus L square. As A is fixed, you can write D1 is to D2 is to D3 is equal to 1 by root over 1 square plus 0 square plus 0 square is to 1 by root over 1 square plus 1 square plus 0 is to 1 by root over 1 square plus 1 square plus 1 square is equal to 1 by 1 is to 1 by root 2 is to 1 by root 3. So you take root 6 as common, or else you get the values to be 1 is to 0.71 is to 0.58. 0.5. This is the answer. You have constitutional undercooling condition for a hypothetical binary alloy of A with solute B. During the solidification shown in the figure, alongside with its binary phase based on the two schematics, one can conclude that the solute concentration in the region X will be dash the average composition of the initial liquid phase. This is also one of an important question. This is a very good conceptual question. So in a given binary phase diagram, as the temperature is decreasing, the solid and liquid phases exist together in this region as solid plus liquid. So until it reaches solid phase, the composition of solute B in the solid phase is always less than that in liquid phase due to partitioning of solute between solid and liquid phases. So in region X, which represents a specific temperature, the position of solid and liquid interfaces, is clear that this falls between the region of S and L. So as you are cooling it from this temperature, it like this comes like this, like this, like this. So at each temperature, wherever you see the composition of uh, solid or liquid is always the solute concentration in solid is less than that in liquid. So the solute concentration will be less than the average composition of the initial liquid phase. Here if you see solute concentration will be less than average composition. You will see on an average. This is because during solidification, the solute atoms are rejected from the solid phase and accumulated in the liquid phase. This causes liquid to become richer in solute. This is known as constitutional undercooling. As a result, the composition of solid phase is less than the average composition of the alloy itself. This phenomena is called fundamental axis. This phenomena is a fundamental axis of solidification and is critical such as alloy casting. Otherwise, it can cause coring also. It can lead to the formation of different microstructure and different properties in a solidified alloy. So overall, it is less than the average composition. Match the entries with the stacking fault. So FCC will have ABC type of stacking sequences. HCP will have, so this is ABC, it is 3. Intrinsic stacking fault will have AB type structure, or else it will be having AB in between. So it is this one. Then the cross-sectional annealing twin boundary in FCC. Annealing twin boundary is nothing but if it is ABC, then there will be mirror image to the plane itself. So it is CBA. So if you consider ABC, A. So along this plane, if you'll see ABC, CBA, CBA. So it is 4. And hexagonal blackening fraction is AB. That is 3142. For an element A, the formation of enthalpy and formation of entropy per vacancy is created as 0.5 electron volts and 3 Kelvin. The equilibrium vacancy concentration at 500 Kelvin is dash into 10 power minus 4. It's given the Boltzmann constant is given as K is equal to 8.6 into 10 power minus 5. So equilibrium concentration vacancy can be given as the frequency mu dash equal to exponential minus delta H HF minus T delta S by KB into T, which is equal to exponential delta H formation. We need to find this one, or delta H formation and the enthalpy is given here actually is 0.5 minus 300 into 3 kb, so it is 3 by kb is 8.62 into 10 power minus 5 into 300. So this is equal to exponential of minus 0.05 by kbt minus 3, because here it is 300 by 300, 3 kb, kbt gets cancelled. So you will get 1.839 into 10 power minus 4. Thus the equilibrium concentration value is 1.84 into 10 power minus 4. So the answer is 1.84. in mole fraction. During the carburization of steel at 950 degrees centigrade, the carbon concentration is measured at as 0.8 weight percentage at a depth of 0.3 millimeter after 1 hour. The time required to get the same carbon concentration at a depth of 0.6 millimeter at the same carburization temperature is dash hours. So it's given like the according to Fick's first law, x square is proportional to dt. So the carbon concentration of 0.3 and the distance is 0.3 after 1 hour, and the depth time required for the same depth is. So x1 square by x2 square for the same diffusion, it will be equal to t1 by t2. So it is given as 0.3 by 0.6 square is equal to t1 is given as 1 hour and t2 you need to calculate. So t2 is equal to 4 hours. The answer is 4. 800 grams of AB alloy of 20 weight percentage B is held at a temperature T1. The weight of B dissolved in alpha at that temperature is. It's one of the tricky question which is given in GATE. It's a very good question. So here it is given as composition of alpha is equal to 0.1. Composition of beta is equal to 0.9 weight percentage of B and weight percentage of B. So F alpha is equal to 90 minus 20 by 90 minus 10, which is equal to 70 by 80, which is equal to 70 by 80 into, if you want to calculate the weight of alpha is equal to 70 by 80 into 800 equal to 700 grams. And now, if you'll see, the weight of B dissolved in alpha at that temperature is. So weight of B dissolved is nothing but 70 into 700 grams into weight of alpha is 0.1 at that percentage because it is 10 percentage given. So it is equal to 70 grams. The weight of B dissolved in alpha at that temperature is 70 grams. Because since alpha contains 10 percentage of B here, everything is in weight percentage. Since alpha contains a 10 percentage of B, 700 grams is 10 percentage of B and 90 percentage of A. So it will be 70 grams and 630 grams of A in terms of B. Thank you.